Hello and welcome to part 2 on infrared spectroscopy, a brief introduction to IR with Dr. Cossey. This is part 2 of 2, so if you haven't seen part 1, you should probably go back and see that first. But part 2 of 2, we're going to talk about more functional groups than what we saw in part 1. So that's going to be for more of the peaks you might see on your IR spectra. Just as a quick recap, in part 1 of the series, we saw a brief introduction about what spectroscopy is and how it works with molecules, and also we talked about IR specifically, and then we were talking about what kinds of peaks you should look for on your IR spectra to try to confirm the identity of some sort of molecule. So some of the functional groups we already mentioned are shown here. These are in the previous video. So these are for the functional groups that don't have carbonyls. So now we're going to see the functional groups that do have carbonyls. So at the end of this video, you should know all the possible peaks that you might need and be able to complete your assignments. So all the ones before we talked about are things that are mostly single bonds and double bond things with carbon. There's also a thing called a carbonyl. So a carbonyl is a C double bond O. If you look on the right, that's what that says. And if you look, there's a lot of different functional groups that have those. So there's all these different examples that I showed. There's actually some that are not shown, but those are a few examples. So you're not just looking for a carbonyl if it has a carbonyl with a different letter on the side. So if you look down here, there's a carbonyl with an OH, there's a carbonyl with an NH, there's a carbonyl with a CO. They kind of look like functional groups we already saw, right? Because we saw like an alcohol, an amine, and an ether. But now because it has a carbonyl directly attached, it reacts differently. Because it reacts differently, that means it's a different functional group. But we still label the IRs the same because we're looking for those bonds, not specifically, it doesn't know if it's a different functional group necessarily, okay? So I divide these up to say if we find a carbonyl, we should be in this section, right? If it's something with a carbonyl. If it's something that doesn't have a carbonyl, we'll do the first section that we already talked about. So it's a convenient way of splitting up the functional groups that we might be able to recognize, okay? And the names here are at the bottom. So this is a ketone, an aldehyde, a carboxylic acid, an amide, and an ester. All right, so if we start looking at these, the first one would be a ketone. A ketone is the most simple example because it has a carbonyl, but that's the only special bond it has. It does have to have a carbon on both sides of the carbonyl. So if you look here at the carbonyl on the left and right, there should be carbons on both sides. That's how we'll tell them apart from all the other functional groups. So the only key peak we have for this is the carbonyl. Carbonyls are always, if you look at the chart, they're in the range of around 1700. That's like about where they are. They're slightly lower usually, but they could be a little bit higher as well. So if you look here, they're a long, sharp peak. So you can see right here in the middle, that's where it is, right? That's a long, sharp peak, and that's what you're looking for. If it's not really long compared to all the other peaks, then that's not a carbonyl peak, right? So that means this one's a ketone because it's the only other peak that we see. All the other carbonyl functional groups should have an extra peak. They should all have a carbonyl, but then something else. So the first example would be an aldehyde. An aldehyde has a carbonyl, but it also has a special hydrogen on the side. Because that hydrogen's next to a double bond, but it's an O, it's a little bit similar to the double bond C, but it's on the other side. So if you look, it'll say this on the chart, but aldehydes have a carbonyl plus the CH peak. The CH peak is this little peak right here. See on the right of the big peak that we're ignoring, right, the middle one? It's that peak right there is the CH peak. So label it like this. So key peaks would be number 1, carbonyl. Number 2, the special CH peak labeled there. Okay? All right, let's keep going. So the next one's a carboxylic acid. So kind of like an alcohol, it has an OH peak. So we'll look there. It has the carbonyl, so we'll label that one first. That's here, right? Again, long and skinny. And then if you look at the OH peak, it does have one, but see how it's like smooshed to the side? It's round, but it's also blended into the 3000 peak, so it's lower. So it's not lumpy like the NH because that was totally separated. So that's how you're going to be able to tell them apart. You can also go back to this part of the video if you need to, right? But that's the OH peak for the carboxylic acid. That's the second key peak that you would label. All right, then next we have the amide. Amides are like amines, right? They have NH peaks, and they should have carbonyl peaks. So the carbonyl peaks here, right? It's around the same range. That's around a little bit above 1600 in this case. So that's our first key peak. Then our second key peak is going to be the NH. Do you remember where that was? Right, it's above 3000. So it's this peak right here. That would be our second key peak. And again, it has 2 lumps because it's NH2 that corresponds. All right, the last of the possible functional groups that you might have for this class is an ester. So an ester, again, like an ether, it doesn't have OHs or NHs, right? There's nothing on this left side, but it should have a carbonyl. That's our first key peak. So where's that? Right, it's right here above 1700, the really long peak. And then it should also have a CO peak. So the CO peak, remember, is between 1000 and 1200. So which peak do you think that might be? Right, it's that really long one, right? Whatever the longest one is, just mark that one. So again, the two key peaks are a carbonyl and a CO bond. Perfect. All right, so that's all the functional groups that you have to know for this class. I just gave lots of examples so that way you could point them out on a picture. If you have a handout, you can match it to that, and then you'll have all the information you need. Now, as I said before, for this class, if it's an intro chemistry class, you're not going to have to identify much based on the IRs. It's usually going to be something, if you think you know what it is, then you're going to look at the shape of the molecule and see if you can confirm that that's what it is, right? So like if we're doing an experiment where we're isolating something from spices, right? Special things from spices, we'll look at the functional groups that we think we know that they're what they are from the pictures. We'll find the key peaks that we are expecting, and then we'll just look and see if that matches what we found. And that's how we'll know if it's the right compound. Okay, but sometimes you are trying to find more information for an IR, like you might have an unknown molecule. So when you're doing that, this is a good strategy to go through that. I'm not going to go into it right now, but if you ever find yourself in that situation, you can pause this video, or we'll probably talk more about it in class as well. All right, so I'm going to stop the video there. Hopefully you found this helpful. If you have any questions, you can always ask Dr. Cossey, and I'm happy to help anytime. Thank you. Bye.